NASA has a knack for building machines that last far beyond their expiration dates. The Hubble has been operational for nearly 33 years and is expected to remain that way until at least 2030. Spirit and Opportunity spent 10 and 15 years, respectively, exploring Mars after completing their primary 90-day mission in 2004. And the Mars Global Surveyor, which launched in 1996, won't decay from its orbit until 2050. Heck, Voyager hasn't touched atmosphere in nearly half a century, but it's still transmitting from beyond the galaxy's edge. But even the best-made satellites make planetfall eventually. Last week, the NOAA's Earth Radiation Budget Satellite, the ERBS, which has circled the Earth since the Reagan administration, finally fell from orbit nearly 4 decades after it went up. But let us not remember the ERBS as it died, a fiery, screaming mass of molten, twisted metal and ceramic hurtling at terminal velocity through the thickening atmosphere towards an ignoble burial at sea, but rather as it lived, a 2.5-ton mass of highly engineered metal and ceramic screaming around low Earth orbit at hypersonic speeds, investigating the planet's radiation budget. Yes, the Earth has a radiation budget. Of course it has a radiation budget. It measures the balance between energy coming into the atmosphere, the shortwave, visible, and ultraviolet radiation emitted by the sun, against the amount of outgoing energy, shortwave radiation that's been reflected back into space, and longwave radiation emitted by both the atmosphere and the Earth itself. Basically, shortwave radiation comes in, some of it bounces off, and some of it gets absorbed and re-emitted as longwave radiation. The Earth's relative levels of incoming and outgoing energy account for the Earth's radiation budget. All of this is measured in watts per square meter. Only a relatively small amount of longwave radiation actually escapes into space. Most of it ends up warming the planet's surface. Basically, greenhouse gases capture energy from long-wave radiation emitted by the planet, which warms the lower atmosphere. That warm air in turn radiates long-wave radiation back towards the planet, warming the surface. As with financial accounting, you really want the two sides here to come out even. With an energy surplus, you get rising temperatures and accelerated greenhouse effects. Hey, that's global warming right there. And energy debt, conversely, results in global cooling trends and eventually mini ice ages. As such, NASA and the NOAA have studied the planetary system closely for decades and in the mid-80s began the Earth Radiation Budget Experiment, or ERBE. The ERBE relied on a trio of spacecraft, 2 NOAA satellites, and the more specialized ERBS. The mission sought to monitor the Earth's average monthly energy budget and its monthly variations, the seasonal movement of energy from the tropics to the poles, and the average daily variation in the energy budget on a regional scale, according to NASA. In all, the experiment was slated to operate for just 1 year. But we're not telling you all of this because of some boring satellite that worked for one trip around the sun in the mid-80s before retiring. No, the ERBS was the Forrest Gump of Earth observation satellites. When it was launched in 1984, the ERBS was taken into space on the Challenger shuttle. Yeah, that one. A mere 3 months before it did what it's famous for. Sally Ride, yeah, that Sally Ride, personally placed it into orbit using the Canadarm, that 50-foot-long, 900-pound tactile crane boom famously used throughout the shuttle era. And on the same mission that put the ERBS into orbit, astronaut Catherine Sullivan performed the first spacewalk by an American woman. That's some pedigree. And after the ERBS completed its primary mission, it continued collecting data for another decade plus. The satellite officially retired from service in 2005, then it just sort of hung around for the next 18 years until its orbital decay finally overcame its momentum and the friction of Earth's upper atmosphere dragged the venerable satellite to its watery grave near the Bering Sea.